So couple of sessions where we've made an attempt to understand the basic ideas, basic rudiments of projectile motion in general, some variations around projectile motion. Yet another one today, which is like, if there is an inclined plane, say if there is an inclined plane making an angle alpha with the horizontal, this is the horizontal level, this is the horizontal level, and this is an inclined plane, and we happen to launch a particle with a velocity u. We happen to launch the particle with a velocity u, making an angle theta with the horizontal, making an angle theta with the horizontal. It will still be under gravity till the time it hits the plane where there would be a collision. It will be subject to an acceleration g downwards as usual, right? It is then going to undertake a certain trajectory, and it's going to hit the plane somewhere. It's going to hit the plane somewhere. Now there are two things of importance that we have to analyze here: the time after which it hits the plane, and the length along the plane that it covers before hitting the plane. This length. The length along the plane that it covers before it hits the plane. These are the two things that would be of importance to begin with. Now, let me call this O. The point from where it's launched, O, the origin of coordinates. And this time what we do is we define a new frame of reference, Along the plane we define as our x-axis. There is no loss of generality in doing this. We can define the x-axis along the plane, right? And we can define the y-axis perpendicular to the plane. Y-axis as perpendicular to the plane. Yes or no? Now, irrespective of what I define as the x and the y-axis, g will still act downwards, right? There is no reason g will misbehave if there is a plane, right? Horizontal. And this is my horizontal. Now, what we are going to do is, in general, we want to know the velocity of the particle in the x direction t seconds later, velocity of the particle in the y direction t seconds later, and so on and so forth, and the time it takes to hit the plane, and the distance covered along the plane before it hits the plane. This time OA would be my revised range. OA then would be my revised range of this projectile, right? So this kind of a motion is commonly referred to as projectile along an inclined plane. This is called projectile on an inclined plane. Along an inclined plane. Right? Now, g will still be downwards. All along, g will still be downwards. Right? Since our frame of reference is along the plane and perpendicular to the plane, it makes sense to resolve g along the plane and perpendicular to the plane. It makes sense to resolve g along the plane and perpendicular to the plane, because this then is our new frame of reference. We'll be talking in terms of x and y. Components along the x and components along the y, right? Now, if this is alpha, very clearly this is 90 minus alpha, right? And a perpendicular to the plane is this. This is perpendicular to the plane, and this is alpha. This is alpha, right? G therefore could be resolved as g cos alpha perpendicular to the plane and g sine alpha parallel to the plane. G sine alpha parallel to the plane. Yes or no? Right? So we have now, since we are talking of the revised frame, the acceleration along the x direction would be minus g sine alpha because it's in the negative x direction. Would be minus g sine alpha. And acceleration in the y direction, this is in the negative y direction, so this is going to be minus g cos alpha, minus g cos alpha. Right? T seconds later, the particle is at a point P. T seconds later, the particle arrives at a point P where it has a velocity in the x direction and it has a velocity in the y direction. It has a velocity in the x direction, it has a velocity in the y direction. At a point P, t seconds later, it possesses a velocity along the x direction, it possesses a velocity along the y direction, right? Now in this case, realize, unlike our previous choice where along the x-axis there was no acceleration, this time there is an acceleration along the x direction, which is g sine alpha, which is opposing velocity in the x direction. So what would g sine alpha do? G sine alpha would retard Vx, Now, realize that again, this was the inclined plane and we launched the particle with a velocity u, right? This angle was alpha, this was theta, so this would have been theta minus alpha. Angle that the velocity made with the plane would have been theta minus alpha. So this is the plane and this is theta minus alpha. U therefore could have been resolved as u cos theta minus alpha along the initial velocity along the x direction. This is the initial velocity along the x direction, which is the inclined plane, and perpendicular to the plane, initial velocity uy is u sine theta minus alpha. Yes or no? Right? Ux is opposed by g sine alpha, uy is opposed by g cos alpha, right? So t seconds later, when the particle is at P, the particle arrives at a point P x comma y. The particle arrives at P x comma y. Its velocity in the x direction t seconds later would be initial velocity in the x direction plus ax into t. Right? Its velocity in the y direction t seconds later would be initial velocity in the y direction, initial velocity in the y direction plus acceleration in the y direction into t. Yes or no? These would be the velocity components in the x and the y direction t seconds later. So this causes Vx t seconds later to become equal to initial velocity in the x direction is, as you can see, u cos theta minus alpha. Initial velocity in the x direction is u cos theta minus alpha, right? So ux is u cos theta minus alpha plus ax. What is ax? Minus g sine alpha. Into t, right? That's the velocity in the x direction. That means parallel to the plane. That's a velocity parallel to the plane t seconds later. Now velocity component perpendicular to the plane means parallel to the y-axis t seconds later is given by this. That is Vy is initial velocity in the y direction. What's the initial velocity in the y direction? U sine theta minus alpha. And what's the acceleration in the y direction? Minus g cos alpha. into t. That's the velocity in the x and the y direction t seconds later, right? Again, when the particle reaches p, when the particle reaches a point p, which is coordinates x comma y, when the particle reaches p, which is x comma y, what is its displacement in the x direction? X. What is its displacement in the y direction? Y. Yes or no? When the particle reaches a point p, x comma y, t seconds later, this is my x-axis. Realize that this is my x-axis and this is my y-axis. On reaching the point p, coordinates x comma y means this is x and this is y. So what's the displacement parallel to the x-axis? X units. What's the displacement parallel to the y-axis? Y units. Yes or no? Right? What causes displacement in the x direction? Initial velocity in the x direction and acceleration in the x direction. What causes displacement in the y direction? Initial velocity in the y direction and acceleration in the y direction. Right? So, the x coordinate of the particle t seconds later would be initial velocity in the x direction t plus half of ax into t squared. That's a displacement in the x direction t seconds later, right? Which is, what is initial velocity in the x direction? As you have seen, it was u cos theta minus alpha. U cos theta minus alpha was the initial velocity in the x direction. Half of ax. What is ax? Ax is minus g sine alpha. Ax is minus g sine alpha. So, t squared. That's a displacement in the x direction. That means displacement parallel to the plane in t seconds. Displacement parallel to the plane in t seconds, right? Now, what is the displacement in the y direction in t seconds? Initial velocity in the y direction t plus half of ay into t squared. What's the initial velocity in the y direction? U sine theta minus alpha. Into t. And what is ay? Acceleration in the y direction, as you can see, is minus g cos alpha. T squared. That's the displacement in the y direction as a function of time, right? So now I have velocity in the x direction as a function of time, velocity in the y direction as a function of time, x coordinate of the particle as a function of time, and y coordinate of the particle as a function of time. These are things that you want to know about the particle, right? Now, what happens to y when the particle reaches a? 0. When the particle reaches a, y becomes 0. Yes or no? Right? That means if you plug in y equal to 0, you should be able to get the time it takes to reach a. At a, what happens? At a, what happens? At a, y becomes 0. At a, y becomes 0. So I have this equation, y equal to u sine theta minus alpha into t minus half g cos alpha into t squared. Now if you plug in y equal to 0, you get two values of t. T is 0, right? If you plug in y equal to 0, one of the values of t will be 0, which happens at O. At O, y is 0 and t is 0. That's one instant of time. The other value of time that you get when you plug in y equal to 0 is 2 sine theta minus alpha by g cos alpha, right? This is what happens. Twice u sine theta minus alpha by g cos alpha is what transpires, which is like What is u sine theta minus alpha? U sine theta minus alpha was the initial velocity in the y direction. So this is like twice the initial velocity in the y direction divided by g cos alpha. This then must be the time taken to reach A. This then must be the time taken to reach A. And this is called the total time of flight. This then is called the total time of flight. This is the time taken to hit the plane again. This is the time taken to hit the plane again. Twice the initial velocity perpendicular to the plane divided by acceleration g cos alpha, which is also acceleration perpendicular to the plane. G cos alpha is acceleration perpendicular to the plane. Right? That's the total time of flight. That's the total time of flight. Now, having said this, look, what all happens? I also want to know OA. I also want to know OA. OA is my revised range. OA is my range along the plane. OA is called the range along the plane. Range of the projectile along the plane under ideal conditions. Now, notice hey, had the plane not been there, the particle would have completed its trajectory. Usual parabolic trajectory it would have executed, right? It just got prematurely intervened by its collision at A. This was the velocity of launch. When it reaches A, it takes time, capital T seconds to reach A. It takes time, capital T seconds to reach A. Yes or no? This was U, and it made an angle theta with the horizontal. It made an angle theta with the horizontal, right? So what was the velocity of the particle parallel to the horizontal? This is not the x-axis, sorry. This was just the horizontal. This is my x-axis. So what is its velocity parallel to the horizontal? Parallel to the horizontal will still be u cos theta. Its component of velocity parallel to the horizontal will still be u cos theta, right? And when it reaches A, this is its displacement along the horizontal direction in capital T seconds. Yes or no? On reaching A, if somebody says, when the particle has reached A, what is its displacement in this direction? The displacement in this direction is this length. And who's responsible for causing this displacement? U cos theta. And u cos theta in this direction will not change with time. Why? Because in this direction there is no acceleration. This was the horizontal direction along which there is no acceleration. That means this displacement must have been caused by u cos theta acting for how long? Acting for capital T seconds. Yes or no? Did you understand this? This displacement in the horizontal direction is caused by a constant u cos theta acting for a total time capital T seconds. Where this angle is alpha. Now, what does this turn out to be? This length L turns out to be u cos theta into capital T. What is capital T? 2u sine theta minus alpha by g cos alpha. That's the time of flight. Time taken to hit the plane again, 2u sine theta minus alpha by g cos theta. Yes or no? right? This is the length L. This is the length L. Now I know, I have knowledge of this length L. What is OA? Is OA not equal to L sec alpha? Is OA not equal to L sec alpha? OA is L sec alpha, isn't it? Look at this right angle triangle. This length is L. So OA will be L sec alpha, right? L sec alpha means this is my L, this is my L, and this into sec alpha. So that will become U squared 2 sine theta minus alpha into cos theta divided by G cos squared alpha. G cos squared alpha. That's my range R along the plane. That's my range R along the plane. Did you all understand this? Did you all understand this? Now, see, I can simplify it even further. 2 sine A cos B. Do you recall the formula for 2 sine A cos B? 2 sine A cos B. Sine A plus B plus sine A minus B. So let me expand this. So this then becomes U squared by G cos squared alpha into sine A plus B sine alpha. If I apply that result, this is what I get, U squared by G cos squared alpha to this. That's a range along the plane. 2 sine A cos B, sine A plus B plus sine A minus B. This is what it gives me. Is there a problem? Got me now? Okay, now notice. So far so good. Do you understand that? Now what I do is, let's say I fix the velocity with which I am hurling, the speed with which I am hurling the projectile, let's say I fix, U is fixed. And there is a given inclined plane. Given inclined plane means alpha is fixed, right? The angle that the inclined plane makes with the horizontal alpha is fixed until and unless I get destructive and I hammer and pulverize the plane to dust. That's another issue, but otherwise I'm talking of a fixed plane and I'm a normal human being and I'm not destroying the plane. So I'm talking of a given U and a given alpha. I'm talking of a given U and a given alpha. But the velocity U is launched at an angle theta which I can vary. Theta with the horizontal can be varied, right? Now what I want to do is I want to model theta. I want to find theta for a given U and for a given alpha. I want to find theta that will maximize my range. You know what I'm saying? I want to find a given theta. I want to find a theta for a given U and for a given alpha to maximize range, right? So for a given U and alpha, we want to maximize R. We want to maximize R. That means theta can be varied. Theta is varied. That means I want to select an appropriate value of theta that will maximize R. I want to select an appropriate value of theta that will maximize R. Hey, realize that this is a fixed number. I can't do anything with it. U and alpha is fixed. This is a fixed number. I can't do anything with it. That means to maximize R, I must maximize this number. When this becomes a maximum, range will become a maximum. Yes or no? That means, and what's the maximum value of sine of any angle? 1. Right? The maximum possible value of this is 1. Yes or no? That means sine 2 theta minus alpha should be a maximum. It could be and equal to 1, 2 theta minus alpha. That must be a maximum and equal to 1. That means 2 theta minus alpha must be 90 degrees. Right? This gives me theta equal to pi by 4 plus alpha by 2. Pi by 4 plus alpha by 2 is what I get. So, if I launch at an angle which is pi by 4 plus alpha by 2, for a given u and for a given inclined plane that is given alpha, then range would attain its maximum value at theta equal to pi by 4 plus alpha by 2. Pi by 4 plus alpha by 2. Right? Now, let me also find the maximum value. So, this is the condition for maximum R. Which means if I plug in this number equal to 1, then R will become R max. If this number is substituted as 1, then R will become R max, maximum R, right? So R max, maximum R is u squared by g cos squared alpha into 1 minus sin alpha. Now this cos square alpha I can write as 1 minus sin square alpha. This cos square alpha I can write as 1 minus sin square alpha, which is 1 plus sin alpha into 1 minus sin alpha. And that 1 minus sin alpha will get cancelled from the numerator. So this then will get reduced to a mere u squared by g into 1 plus sin alpha. 1 plus sin alpha. That's our max. That's the maximum value of R. Did you all understand this? That's a maximum range achievable along a plane by causing theta to become pi by 4 plus alpha by 2. Alpha is the angle of the plane. Sure, no? Now, all's good so far, right? Can I remove the clutter from here? Everything is fine, right? Now, look, this is the highest point above the plane. This is the highest point above the plane. P, highest point above the plane. This is the highest point above the plane. That means at this point, Vy must have become 0. At this point, Vy must have become 0. And there would have been some value of Vx. In this case, Vx does not remain constant. Why? Because there is an acceleration along the x-axis, so Vx is not constant in this case. But Vy has to be 0, because if Vy was not 0, it would rise further. It stops rising further when velocity parallel to the y direction becomes 0. So that's the highest point above the plane in this direction, right? Hmm? Suppose the time taken to reach this point is t. Now do you recall Vy, velocity in the y direction, in t seconds is u sine theta minus alpha minus g cos alpha into t. That's the velocity t seconds later, which I demonstrated a little while ago, right? Now Vy becomes 0 for t equals u sine theta minus alpha by g cos alpha. This is the time taken to reach the point P. This is the time taken to reach the point P. How about it? This is the time taken to reach the point P, right? And do you realize that this is half the total time of flight? This is half the total time of flight. This is half the total time of flight. The total time of flight, as you would have seen, is 2u sine theta minus alpha divided by g cos alpha. That's the total time of flight. 2u sine theta minus alpha by g cos alpha. That's the total time of flight, right? And half of that is the time taken to reach the highest point. Now I have a question for you. Conceptually answer this question. OA, and this point is, say, M. OA is range R, right? Which we have figured out. U squared by g cos alpha into sine 2 theta minus g cos squared alpha sine 2 theta minus alpha minus sine alpha. We obtained the value of R. Now if this is R, what can you say about this? If this is R, OA is R, what can you say about OM? Equal to R by 2, less than R by 2, greater than R by 2, or the last option, God knows. Will this be R by 2, greater than R by 2, less than R by 2, or who cares? Can I have a referendum here? R by 2, how many of you R by 2? Okay. Greater than R by 2? Greater than R by 2? Less than R by 2? Okay. Some people have not committed to anything. So because the union of whatever responses I get is not the strength of the class. So some people choose to not respond. See, this was the velocity u with which it was launched, right? And there was a retardation in the x direction, x-axis. There was a retardation in the x direction, right? There was retardation in the x direction. Now when the particle reaches P, OM is the displacement in the x direction. When the particle reaches A, OA is the displacement in the x direction. Yes or no? Now from O to M, the particle got continuously retarded in the x direction. And from M to A, again it got continuously retarded in the x direction. But the time taken for the displacement OM is the same as the time taken for the displacement MA. Yes or no? Because this time is capital T by 2. Right? That means time for this displacement is capital T by 2. And from here to here again T by 2. Right? That means time taken for the displacement MA is also T by 2. Yes or no? Time displacement for the time taken for the displacement OM is, that means O to P, displacement is OM and time taken is capital T by 2. Then when it goes from P to A, displacement in this direction is MA and that time is also capital T by 2. Yes or no? But do you realize that velocity in the x direction is continuously reducing? The velocity in the x direction is continuously reducing. So would you not want to believe that the average velocity from O to P in the x direction would be higher than the average velocity in the x direction from P to A? Because velocities are decreasing. Yes or no? In the x direction, velocities are continuously decreasing. And if the velocities in the x direction are continuously decreasing, then in the same time, t by 2 and t by 2, the average velocities here in the x direction would be less than the average velocity in the x direction in this displacement, right? So would you not want to believe that since the velocities here would be higher in the x direction than the corresponding velocities here for the same time, that means this displacement has to be more than this displacement? That means this has to be greater than r by 2 and this has to be less than r by 2. Yes or no? Very contrary to our initial belief, where we were forced to accept that or resigned to understand that this will be r by 2 and this, no, this will be greater than r by 2 and this will be less than r by 2. Did you all understand what I'm saying? I'll explain again. Okay, think about it like this. Think of one-dimensional motion. Let's say there is a particle u. Think of it very simply. Think of one-dimensional motion. There is a particle u and there is a retardation a like this. Now, in, let's say, t0 seconds, particle goes from O to m. And then from m to a in another t0 seconds. In another t0 seconds, the particle goes from m to a. Right? Now tell me whether OM will be more or MA will be more. OM should be more now, because see the velocities here are higher than the velocities here because it's continuously retarding. So in the same time the displacement here has to be more than the displacement here. Yes or no? Because the velocities here at every instant will be higher than the velocities here at the corresponding instant, right? Right? So displacement here would be higher than the displacement there. Yes or no? So same thing. Now what I do is, I'm talking of displacement in this direction. In this direction, the particle has an initial velocity ux and has a retardation ax. Now this kind of a displacement takes place in capital T by 2 seconds, and then in the remaining capital T by 2 seconds, this kind of a displacement takes place. And there is a continuous retardation ax in this direction. So will this displacement not be more than this displacement? Right now? That means if this whole thing is r, this has to be greater than r by 2 and this has to be less than r by 2. Yes or no? Is the idea clear? Now, let me find when the particle reaches A, how long does it take? Capital T seconds, which is 2u sine theta minus alpha by g cos alpha, right? Let me find the velocity of the particle when it reaches A. Velocity in the x direction, that means on reaching A, would be initial velocity in the x direction plus ax into t. Velocity in the x direction was u cos theta minus alpha. Initial velocity in the x direction plus ax, which is like minus g sine alpha, and what is t? T is 2u sine theta minus alpha by g cos alpha, right? Which obviously is different from ux. That's the velocity in the x direction when it reaches x. That's the velocity in the x direction when it reaches A. When it reaches A. Yes or no? Now, velocity in the y direction when it reaches A. Initial velocity in the y direction plus ay into t. That's the velocity in the y direction when it reaches A. That's the velocity in the y direction when it reaches A. What is uy initially? U sine theta minus alpha. What is ay? Minus g cos alpha. And what is t? T is 2u sine theta minus alpha divided by g cos alpha, right? And do you see that this g cos alpha gets cancelled? This is like minus u sine theta minus alpha. Yes or no? Do you realize this? That means when the particle goes from O to A, see, in the y direction at O, it had a velocity u sine theta minus alpha initially. And when it reaches A, it has minus u sine theta minus alpha in the y direction. That means u sine theta minus alpha in the negative y direction is what it has. Yes or no? That means the magnitude of the velocity perpendicular to the plane initially is magnitude of the velocity perpendicular to the plane when it hits the plane. That means if it was launched with a velocity u and its velocity component perpendicular to the plane was 5 meters per second, then on hitting the plane, its velocity in the y direction would change direction. It would be in the negative y direction, but would be of the same magnitude. That means if this was 5 meters per second, this will also be 5 meters per second. This was emerging out of the plane. This is digging into the plane. Yes or no? God bless you. Does it make sense to all of you? Are you all okay with this? Adya? No, I can run over this again. Did you understand velocity in the y direction? No, Vy is not 0, y is 0. At A, Vy is not 0, y becomes 0. Y becomes 0 at A, not Vy. Are you all doing good with this? Please ask. Suppose, yeah, I'll tell you what you have to do is ux into capital T by 2 plus half of ax into capital T by 2 squared. That will be the value of OM, isn't it? Displacement in the x direction in capital T by 2 seconds is OM. Initial velocity in the x direction, which is u cos theta minus alpha into T by 2, that will be the value. Right? Confusion? But that's not constant, no? Into T by 2, u cos theta minus alpha is not constant in this case because there is ax.
No, I am taking the component of u along the horizon.
You can, okay, then that's fine. You can do this u cos theta into capital T by 2 into sec alpha. Fine. No, then, wait. No, this is what you'll have to do. This. When it reaches P, this is the displacement. Not this. This will be u cos theta into capital T by 2 seconds. And into sec alpha will give me only this, not this. Right? Will give me this, but not this. Right now, that's how you got a different result. Got me? Exactly. It's good to go wrong sometimes because you learn. Most of the time, I'll tell you, maximum amount of learning comes to us by goofing up. Trust me. So every time you goof up, don't feel low about it, feel good about it. So far so good, right? Shall I proceed then? Do you also know who your best teacher has been from the time you started to, let's say, see things around you, understand things around you, your best teacher has been you yourself. Trust me, you've learned more things out of yourself than those that have been imposed upon you. Unfortunately, when we grow up, we get very synthetic about our views on learning, and we start to believe that our learning is dependent on external factors. You know why you learn very fast when you're a small kid? You know why you learn very fast? Because you're not dependent on external factors to teach you. You know, it is, you're not yet contaminated with these surroundings. Surroundings have not had an influence on you. Okay, you know, there has to be a teacher to teach you. You know, your mind understands that you will learn by yourself, or rather it understands nothing, and therefore you learn by yourself. And that's the time you learn the best and the fastest, right? See, you learn your language, your mother tongue, when you learned how to talk reasonably fluently when you were what, maybe 4 or 5 years old, right? When you, but bring up a grown up, ask him to stay, he stayed in one state, bring him to another state, and give him that many years, he wouldn't have learned how to speak, talk, read, and write as well as you did in your those initial 4 years. That's because this guy is dependent on external factors for his learning. You were not dependent on external factors. You were dependent purely on your own neurons firing up at the right time, you know, and they fired, they obliged. But your learning becomes slow, gets impeded when your dependence on external factors, external teachers, external mentors becomes overbearing and tyrannical. So, I think that's a tragedy of human race, classical tragedy of human race, that, you know, when while our children grow up, we expose them to so much of synthetic forms of learning that the natural course of learning goes into oblivion, and we suddenly start to believe why this guy, as he's growing up, he's learning at a smaller rate when he learned when he was a smaller kid, right? Isn't it? Right. Now, a variation to this. You know, there is a particle. This is an inclined plane, but this time, instead of launching up the plane, I'm going to launch a particle down the plane. Instead of launching a particle up the plane, I'm going to launch a particle down the plane. You know what I'm saying? This is my O. And I'm going to launch a particle like this with a velocity u, with a velocity u. That makes an angle theta with the horizontal. That makes an angle theta with the horizontal. So obviously this angle will be alpha, alternate angles, right? This angle will be alpha, alternate angles. Now this is my new launch, and I want to find the time the particle takes to reach A, that is hit the plane again, and I want to find the new range down the plane. O is my range down the plane, right? U is the velocity with which I have launched the particle, and it makes an angle theta with the horizontal, but makes an angle theta plus alpha with the plane. Yes or no? Now my first take on it. I don't want to reinvent the wheel, but I will. To drive home a point, I'll reinvent the wheel, but I'll tell you, I did not have to reinvent the wheel. Trust me, my earlier inclined plane was like this. This was an angle alpha. This was u. And this angle with the plane was theta minus alpha. Right? was theta minus alpha. That's how I launched the particle. And the time of flight I got was 2u sine theta minus alpha by g. This is what I got as the time of flight. And the range along the plane, that means my OA, which is my range along the plane, I got as u squared by g cos squared alpha sine 2 theta minus alpha minus sine alpha is what I got. Yes or no? This was my range along the plane. This time, now what happens to AX and AY in the two cases? Whether I launch the particle up the plane or down the plane, AX and AY will have the same direction. AX, that means acceleration in this direction will continue to be g sine alpha. Acceleration perpendicular to the plane, digging down, will be g cos alpha. That will not depend on whether I am launching the particle up the plane or I am launching the particle down the plane. That will remain intact irrespective of how I launch the particle. Yes or no? Right? Now, what then is the difference between this situation and this situation? In this case, u makes an angle theta plus alpha with the plane. In this case, u makes an angle theta minus alpha with the plane. Right? That means what's the difference? In this case, it makes an angle theta plus alpha with the plane. In this case, it makes an angle theta minus alpha with the plane. That means when I go from this to this, it's essentially alpha has been replaced by minus alpha. Yes or no? When I migrate from this situation to this situation, what has essentially been done? Alpha, if you replace by minus alpha, this will become theta plus alpha. Yes or no? That means now I claim, and you will witness that with the white of your eyes, that in the time of flight in this can be obtained from the time of flight in this on replacing alpha by minus alpha. That means if you replace alpha by minus alpha, this will become sine theta plus alpha, and that will be the time of flight in this. If you replace this alpha by minus alpha, that will give you the range along this plane. Easy to see. Easy to see. Let's see. Since you're looking at me with skepticism, I will go ahead and derive this result for you. Right? I know you're looking at me with a lot of disbelief. Okay. In this case, this is my y-axis, this is my x-axis. Okay? And like before, the acceleration in this direction is like g sine alpha, and acceleration perpendicular to the plane is g cos alpha. That means parallel to the y-axis. Yes or no? This is what it is. Now, the displacement, see, initial velocity in the y direction is what? U sine theta plus alpha. And velocity in the x direction initially is u cos theta plus alpha. U cos theta plus alpha. Yes or no? What's the displacement in the y direction as a function of time? Initial velocity in the y direction into t plus half of ay into t squared. That's a displacement in the y direction as a function of time. Y is ut plus half at squared applied in the y direction. Confused kya? Not at all, na? Boss? Clear? Not clear? सच बोलो. मैं तुम सच नहीं बोलते, ये बहुत दुख होता है मेरे को. सच बोलो. Very good. चलो. What is uy? Initial velocity in the y direction is u sine theta plus alpha. What is ay? Ay in this case, acceleration in this direction, minus g cos alpha. Ay is minus g cos alpha. Yes or no? So when it reaches a, what happens to y? 0. On reaching A, y becomes 0. At A, y is 0. Uy is u sine theta plus alpha. Half ay is g cos alpha. This will give me the instant of time t when y becomes 0. This will give me those instants of time t when y becomes 0. Evidently, y is 0. This gives me two values of time, t is 0 and t is 2u sine theta plus alpha by g. G cos alpha. Yes or no? And this was g cos alpha. I'm sorry. This was g cos alpha, which I missed out. Fix this. 2u sine theta minus alpha by g cos alpha. I goofed up a little bit. Right? Hey, could I have obtained this result from this result by replacing alpha by minus alpha? Isn't it? I could have obtained this result from this result by replacing alpha by minus alpha, right? So the time of flight is, because cos minus alpha is the same as cos alpha. Similarly, so this becomes my total time of flight. Similarly, in this case, the range could have been obtained by replacing alpha by minus alpha. If I replace alpha by minus alpha, this will become sine 2 theta plus alpha, and this will become sine minus alpha, which is minus sine alpha, so this will become plus sine alpha. This will remain cos square alpha only. Clear, na? So the new range is u squared by g cos squared alpha into sine 2 theta plus alpha plus sine alpha. This is range down the plane. This is range down the plane. This is the time of flight down the plane. Again, in this case, when is r equal to r max? For a given u and for a given alpha. When this becomes equal to 1, that means when sine 2 theta plus alpha becomes equal to 1. When this becomes a maximum, this range will become the maximum it could be. When sine 2 theta plus alpha is 1, that means when 2 theta plus alpha is pi by 2, that means when theta is pi by 4 minus alpha by 2. In the earlier case, it was pi by 4 plus alpha by 2. On replacing alpha by minus alpha, you get this, the condition for maximum range. Yes or no? And to find R max, what would you do? You would replace this by 1 to get R max. You would cause this to be 1. So that's going to be u squared by g cos squared alpha. This becomes a maximum, 1 plus sine alpha. And this cos square alpha I can write as 1 plus sine alpha into 1 minus sine alpha. So this becomes u squared by g into 1 minus sine alpha, which again is obtained on replacing the previous result, alpha by minus alpha. You get this. You didn't have to reinvent the wheel. Up the plane and down the plane, all that you need to do is remember results for up the plane, for example, and replace that result by replacing alpha by minus alpha. You get the results for down the plane. That's all. That's all. Now the difference here is, now you tell me this. Okay, again you will get, if this is the total time, time taken to reach the highest point will still be capital T by 2. Now tell me, will this be greater than r by 2 or less than r by 2? This will be less than r by 2 because this time it's accelerating in this direction. So in the same time, its displacement in this direction will be less than the displacement in this direction. Because now here it has greater velocities in this direction. Because it's supported by g sine alpha. In the earlier case, it was opposed by g sine alpha. So this will be greater than r by 2 and this will be less than r by 2. Yes or no? Perfect? All's fair? So, you know, relatively simpler sense, you do understand the basic tenets associated with projectile motion. Do understand basic tenets associated with projectile motion, right? Not a problem.